Hey guys, this video is about converting from the first leg of the mole map from representative particles here in the bottom right to moles in the middle, and then going from moles to representative particles on the right. So if you look here, this is called the mole map because it's basically a road, and you have the dashed yellow lines here, and then if you go from representative particles to the mole, you have a conversion factor up here, 1 mole over Avogadro's number. Then on the bottom, if you go from mole to representative particles, you have Avogadro's number over 1 mole. Okay? So let's take a look at an example here. In this case, we're going to go from mole to representative particles, and then representative particles to the mole. So let's take a look at what we have here. Okay, so sample 1 is 2.3 atoms of silver. I want to convert it to moles of silver. So in this case, if you look at the mole map, you want to go from the right to the center. You want to go from the representative particles to the mole. So in this case, you're going to use the conversion factor that has Avogadro's number on the top and mole on the bottom. So let's set it up. So we're going to be given 2.3 times 10 to the 25th atoms of silver. And we want to use our conversion factor, okay, which is going to be 1.0 mole Ag over Avogadro's number, 6.02 times 10 to the 23rd. Okay, particles, but there's 3 types of representative particles: atoms, formula units, molecules. In this case, we're looking at an element, so it's going to be atoms. So atoms Ag. So now we have our atoms here, and our atoms here can cancel. Okay. Now, we have a multiplication problem, 2.3 times 10 to the 25th times 1 divided by Avogadro's number. So, just to save room, I'm going to write the answer down here. Okay. So we get, in this case, 38 mole of silver. Okay, so that's the first one. Now let's take a look at the second one here. All right, we're given 3.8 times 10 to the 25th molecules of water. And we want to go to moles of water. So let's start out with our problem here. 3.8 times 10 to the 25th molecules of water. Okay, we want to multiply it by the conversion factor that we need. Okay, so that's going to be the conversion factor that has 1 mole water on the top. Okay, divided by Avogadro's number, 6.02 times 10 to the 23rd molecules of water. Okay, molecules of water cancels out, molecules of water cancels out. Now we have 3.8 times 10 to the 25th times 1 divided by Avogadro's number, 6.02. Okay, in this case we end up getting equals 63 moles of water. Okay, and our sig figs match. 2 sig figs, 2 sig figs. Okay. Now the next problem I want you to try on your own. Okay, sample 3. You have 8.4 times 10 to the 24th formula units of NaCl. Okay, convert to moles NaCl. All right. All right, so for this answer, you should get equals 14 moles NaCl. Okay. So if there's any confusion, let's take a look at the setup. 8.4 times 10 to the 25th. Okay, instead of writing formula units, it takes all day. What I'm going to do is I'm going to write funds. Okay, we can't write FUs, we can write funds. So NaCl times 1 mole NaCl. Okay, the funds and the funds will cancel out. Okay, or formula units, giving us the 14 moles. So 8.4 times 10 to the 25th times 1 divided by Avogadro's number equals 14 moles. Okay, now let's look at the reverse situation. Let's go in the opposite direction. I'll just show you 2 of those examples. So we're not going to go from representative particles to the mole, the right to the left. We're going to go from the center, the moles, to representative particles. Okay, so let's take a look at 2 of those examples. Okay, 1.3 mole of Hg. Now, we're starting out with a different unit here. 1.3 mole Hg. So you're at the center of the mole map. Now you want to go to the right. Okay. Now remember, Hg is an element, so that is basically what we're going to say is an atom. Okay. So, how this works is we're going to have to use the reciprocal for the formula, or the conversion factor. So it's going to be 1.0 mole Hg on the bottom, and Avogadro's number on top. Okay, and we're going to put atoms here. Hj. Okay. So 1.3 mole Hg cancels mole, and 1.3 times Avogadro's number divided by 1. Okay. And we're going to get 7.8 times 10 to the 23rd atoms Hg. Okay, so we have 2 sig figs, 2 sig figs. So we're using the reciprocal of the formula here. So let's take a look at sample 5. All right. All right, now we have 5.6 moles of carbon disulfide. Okay, this right here is a molecular compound, so we're going to call this molecules. Okay, I always remember the water molecule from biology. Water is 2 nonmetals, so when you see 2 nonmetals, think of water molecules. Okay. So we're going to set this up here. We're going to have 5.6 mol CS2 times our conversion factor. And we have Avogadro's number up top. Okay, we're not going to write atoms, we're not going to write particles, we're going to write molecules, okay, because it's a non-metal. So molecules CS2. Okay, mol cancels out, mol cancels out. Okay, so we're going to multiply 5.6 times Avogadro's number divided by 1. And we're going to get a nice number, 3.4, 2 sig figs. Okay, so 3.4 times 10 to the 24th molecules of CS2. All right, let's look at the last example since we have a little bit of time. Okay, all right, so we have this one. We have ALF3. This is our formula units, or we can say funds. Okay, so we want to go to mol to representative particle. So this one is pretty simple. So we have 10.1 mol ALF3, and we're going to multiply it by our conversion factor that we've been using. So we have mol in the numerator, we're going to have mol in the denominator here. Oops. And we have Avogadro's number up top as part of the conversion factor. Okay, now we have to write funds here because it's an ionic compound. ALF3. Okay, so mol cancels out, and that's it. 10.1 times 6.02, we're looking for 3 sig figs. So in this case, we have 6.08 times 10 to the 24th funds. ALF3. Okay, so that's where we're stopping. For a lot of kids, moles can be a little confusing, but please refer to the mole map and note that representative particles can be 3 different types of compounds: your atoms, your molecules, your formula units. Okay, if you're confused on like, I don't even know where to start, I don't even know where to go, the first thing you want to ask yourself, what is given in the problem? The second thing is, where do you want to go? So find it on the mole map, the starting location, and find out the ending location. All right, then look at the conversion factor that you're going to obtain from the mole map. Okay, and hopefully everything cancels out for you and you shouldn't have any problems. All right, guys, until next time.